Hey class, Absolute 5 here, and today we're going to talk about the fourth part of exponents. Now, I did say it was going to be a 4 or 5 part video. It might be a little bit longer than that because I didn't calculate certain other elements in the content I was making at first. So it might be a little bit longer than 4 or 5 parts, so bear with me. Okay, now, this is part 4 of exponents. And it's going to be about the power of quotient. Now, I already talked about whole numbers and bases, but now what happens if I were to give you this example? If I gave you x over y, and that's being raised to the third power. Now, when you see a fraction, you might start flipping out like, what the heck is that? How am I supposed to do that? Again, let's trust the system and say we're going to write this out that many times based on what the exponent has said. So I write this as x over y over x over y, sorry, not over, times x over y. They're being multiplied. And if you were to add each one of these exponents in the numerator and the denominator, I would get x to the third over y to the third. Therefore, essentially what you're telling me is what you're saying that what I can do is what you're saying is I could just simply say x over y to the third is basically where you just simply distribute the x and the y. Whenever you see an exponent in the numerator, you distribute it in the denominator as well. So remember, don't forget there's a little 1 in the x and there's a little 1 in the y. So that's 1 times 3 is 3, which is x to the third, and 1 times 3 is 3, which is y to the third. Okay? So let us discuss this concept in more detail and in general. So in general, and this is for the power of quotient rule, if again, not m and n, it's just n, if n is a positive integer, I went too far down. And A and C are real numbers, then A over C to the n is equal to A to the n over C to the n, where C is not equal to 0. Obviously, every time we have to make a formula, every time we make a theorem like this, we always have to, when we have a quotient, we always have to specify 0 not being in the denominator because we still don't know what that is at this moment. All right. So let's have this example. Y over 7 being raised to the third power. Now, it's very tempting to just put y to the third and just put 7, but then you forget about that 7 is also being affected by the exponent. Sorry, let me just make this a little bit cleaner. So this is 1 and this is 1. So therefore, this is going to be y to the third over 7 to the third. But remember, you have to simplify. This you can actually work out. Y to the third would be, 7 to the third is, I believe, is 243 as well. Actually, no, I'm wrong. See, good thing I remembered. I just remembered it's not 243. I believe it is 343. You know what? Just to be sure that I got it right on camera, let's work it out. 7 times 7 times 7. This is 49. 7 and 7 is 49. And 49 times 7 is 63. And then 7 times 4 is 28. Plus 6 more is 343. I knew I was right the second time, not the first time around, unfortunately. Anyway, let's not use such big numbers. Let's try to understand the concept. So let's see if I were to have given you m over n being raised to the 7th power. What would that be? M to the 7th over n to the 7th. And you'd be done. Let's try a little bit harder one. 2x to the 4 over 3y to the 5th being raised to the 4th power. Now, you see, now this is where it got complicated very fast, you see? So again, take your time when you're doing these types of problems. When you know that there's so much things to keep track of, you're going to be like, oh my God, I make a mistake, and you're going to be upset. Take a deep breath, and let's observe the problem. So first off, let's label the ones where we need to see the ones. Otherwise, we're going to forget about them when we're going to try to distribute this. So remember, this 4 is not only going to go in the numerators, but it also has to go in the denominators as well. Okay? So let's do the numerator first. 2 to the 4, because 1 times 4 is 4, and then x will be 4 times 4 is 16. So then you have 3 to the 4, y to the 20th. But again, most cases, these types of problems, you need to calculate what they are. So 2 to the 4th is 2 times 2, which is 4, times 2, that's 8, and then times 2 again, that's going to be 16. X to the 16th over, and we calculated this before, 3 to the 4th is 81, y to the 20th. Okay? Whoopsie. Too many errors. Let's try another one. Let's say I had 3y over 4s. This is an s, not a 5. That's an s. I wasn't done. With a PG, RPG over SUV, sure, why not? That kind of rhymed, I think. To the 2nd, to the 4th, and to the 5th. Let me make that look like a 4. 7, 6, and let's make that be a little smaller, to the 3rd. And just square everything. So, this is a mess. And you got to take one step at a time. So remember, first thing is first, put the little 1 there and put the little 1 there for the numbers, for the base, so you don't forget to extend or distribute the 2 into everything in the numerator and everything in the denominator. So this would be 3 to the 2nd, r to the 4th, p to the 8th, and g to the 10th, all over 4 to the 2nd, s to the 14th, u to the 12th, and v to the 6th. And finally, remember, don't forget, you have to calculate what's 3 squares. It's 9 over 16. So RPG, this is 4, this is 8, this is 10, with an SUV, 14, 12, and 6. So let me give you your homework problem to do, optional homework. 5x to the 6th over 9y to the 3rd getting all squared. So that's the lesson for you guys. I hope you enjoyed it. Leave your answers down in the comment section below. Like, share, subscribe to my channel. I forgot what I was going to say. Right. And I'll see you guys next time. Oh, right. Mash the bell button. See, I always forget to mash the bell button. And I'll see you guys next time with another video. This has been Absolute 5. I'm Roger Palomino. Math is infinite because there are infinitely many possibilities. And don't forget, don't hate, calculate.